Today we're going to learn how to label seasons on a two-dimensional diagram. On a test or an assessment or on a worksheet, you would get a question somewhat like this. At position B, what season is it in the northern hemisphere? And you would have to know which season is represented at position B for the northern hemisphere. So I want to go over a couple of rules and steps that we use to learn how to identify what season it is in the northern and southern hemisphere. The first thing I do is I always label my northern hemisphere first, because that is where we live in the United States. In Texas, we live in the northern hemisphere. And then I label the southern hemisphere. So what you want to first do is understand that at position A, B, C, and D, I have a picture of the Earth. We have learned that it is the Earth's tilt that is the main cause of seasons, along with its revolution as it travels around the sun. So if you'll notice in the diagram, the Earth is at a 23.5 degree angle, and each Earth is tilted in the same direction. So they're all tilted at 23.5 degrees, and your northern hemisphere, if you look at that northern part of the axis is actually tilted towards the North Star in each position. Position A, B, C, and D, all of them in the northern hemisphere, they are all, the axis is tilted towards, you can see, the North Star. As the Earth travels around the sun 365.25 days out of a year, it always maintains that position of the axis tilted towards the North Star. So that's going to stay in place as it travels around the sun. If I'm trying to decide what season it is at position A, B, C, and D, this is where I would start. First thing you need to understand is you're going to divide the globe in half according to hemispheres. The top half is obviously the northern hemisphere, and the bottom half is the southern hemisphere. Now, in teaching my students how to label seasons, I always start at the west and east position, or the left and right positions for the globe. Okay? At the left and right position, you are going to line your pencil, or whatever utensil you're using, you're going to simply line it up along that axis there. Okay? You're going to line that utensil up. Okay? What you can see is that the top half of the utensil is tilted towards the sun, whereas the bottom half of that utensil is tilted more away from the sun. You can actually use two utensils, and I line my pencil up on the axis, and you can see that in the northern part of position C, the northern hemisphere of the axis is actually tilted more towards the sun, as opposed to, look at position A, you can see that this pencil in the northern part is tilted more away from the sun. When the northern hemisphere's axis is tilted towards the sun, we would say at this position it is summer. If it is tilted away from the sun, then in the northern hemisphere, this season would be winter. The globe also, the Earth also travels around the sun in a counterclockwise position. So you want to note somewhere on your diagram that it's going to move counterclockwise, which is opposite of clock. That's the direction that it travels. And so if you're trying to determine the rest of the seasons, you would just go in order. So if this is winter, then the next season that follows winter is going to be spring, and we're just labeling the northern hemisphere. Then you have summer, and the season that follows summer is fall. to double check ourselves. If this were a 3D model instead of a two-dimensional model, position B, this globe would actually be behind the sun, and position D would actually be directly in front of the sun. And so what you would see at position D and B is that the axis is not really tilted towards the sun or away, it's just directly in front of it, or it's just directly behind it. And so at position D and B, the globe is actually going to get equal distribution of sunlight energy. And that's why spring and fall have more equal temperatures during those seasons. So now let's seek to label the southern hemisphere. When we're labeling the southern hemisphere, the only thing you need to remember is that the southern hemisphere is always going to be the opposite season to the northern hemisphere. So if at position A it is winter in the northern hemisphere, then we know that it's summer in the southern hemisphere. And you can see this to be true because if I were to line up the axis again, you can see that the bottom half, the axis is tilted more towards the sun than the top half. If you see that pencil, the top half, the pencil's tilted away, and then the bottom half is tilted more towards the sun. And so that's how we identify that. Opposite of spring is obviously fall. So if it's spring in the northern, it's fall in the southern. Over here at position C, it's summer in the northern hemisphere, and it is winter in the southern hemisphere. And you can see if you line up that pencil or utensil along that axis, you can see that the bottom half is tilted away from the sun, which makes the southern hemisphere winter, and the top half, the axis, is tilted more towards the sun, so that's going to be summer. And then position D, the southern hemisphere would be spring because it's opposite of the fall. Now, your left and right positions on a two-dimensional diagram are always going to be summer or winter because of the way that it reads or appears on a two-dimensional diagram. If the North Star were flipped to this left side, then all of the Earths would be tilted towards the left instead towards the right. So you would have to do the same thing, line up to determine, and then it would just, essentially it would just flip-flop. So you want to be aware of that when interpreting the diagram, that if the North Star is on the other side, then that would flip your seasons. So you just need to line up the axis. Remember, if the axis is tilted towards the sun, it's summer. If the axis is tilted away from the sun, it's winter. And if the axis is neither tilted towards or away from the sun, but directly in front of it, or lined up with it, it's going to be the spring and fall season. So that is how you label the seasons diagram and interpret the seasons.